Hey guys, this time we're going to be talking about subnetting IPv4 networks. Now the first thing we need to understand is what is subnetting. Now subnetting is the process of breaking down a chunk of given addresses into smaller chunks. So the next thing we need to know is why. Why would you do this? One of the first and probably the biggest reasons is to break down broadcast domains. So in a large subnet you're going to have a ton of hosts, thousands even. Where if you send out a broadcast to all 1,000 hosts, you would be using a ton of bandwidth. Just a literal huge amount. So if you break this down into small groups, you'll be using a smaller amount of bandwidth. The second reason, of course, is with the limited amount of IPv4 addresses, you may want to try and conserve addresses, which is really important. The ability to conserve addresses in IPv4 is essential. Alright. The next thing you need to have is you need to be able to take and separate users into logical groups. It's an administrative thing. It'll make it easier to isolate security risks and problems and fix them. So for administrative and security purposes, you'll also use subnetting. So those are the three major reasons you're going to use subnetting. Now that we know what subnetting is, let's kind of talk about subnetting a network. Okay. We're going to take and say an internet service provider has provided us with a chunk of addresses. The chunk of addresses is going to be 205.192.0.0/16. So that means that we have a subnet mask of 255.255.0.0. We've got 16 bits active, or 2 octets, fully active. Alright, so we're going to state, our company needs us to break this down into 3 chunks. But they want us to conserve all the leftover IP addresses in a pool at the end. So they don't want us to use these IP addresses. They want us to put them in another subnet, all to its lonesome. So what we're going to do is we need to calculate how we're going to break this down. So let's say Group A has 1,021 users. Group B will have 508 users. And Group C will have a measly 60 users. So we need to break down this network into 3 chunks, with a leftover chunk, which we're going to call Group D, and that's going to be all remaining addresses. So we're going to start with Group A. We have an address of 205.192.0.0. That means that because of what our service provider gave us, these are solid. We can't change these. They're set in stone. Not ours to change. These 2 octets are entirely ours. So we can take and do anything we want with to break down those 2 octets. So what we need to do first is we need to find a subnet that is going to allow us to put 1,021 users in it. So let's figure it out. Wait, how are we going to figure it out? That's what you're asking yourself right now. So I'm going to show you the cheater's way. It's really fast this way. The formula is 2 to the nth power minus 2 equals the number of users. Now, let me explain this formula. 2 to the nth power, of course, is the formula for binary. Every time you have a bit, you have 2 times 2 times 2 times 2, because you have 2 options, times the option above. So, for instance, let's look at the binary value. If we had 2 options, if we have 2 bits, we have the options 0, 0, 0, 1, 1, 0, and 1, 1. We have 4 options because we have 2 bits, so 2 to the 2nd power equals 4. Okay, the next part of this equation is the minus 2. Now the minus 2 subtracts your network address and your broadcast address, which is a requirement for every subnet. Every subnet must have its own network address and it must have its own broadcast address. So you have to subtract those out of the mix of usable user space. So, what we're going to do is first we need to take and calculate how many users, what's the closest number we can get to this amount of users. Well, the first thing we actually need to do is we need to add 2 to this number of users, because we're going to take and move this to the other side. So we're going to add 2 to both sides. So that means 2 to the nth power equals number of users plus 2. Just basic arithmetic. So in this case, we need 1021 users plus 2. So 2n needs to be equal to at least 1023. It needs to be greater than. Alright? So, the easiest way to do this is with a calculator. I'm not going to lie. You don't want to try to work with square roots by hand or powers by hand. However, in this case, I did previously look it up, and 2 10 times equals 1024. Alright, so 2 to the 10th power equals 1024, which is bigger than 1023. So, it's going to be the closest one we can get. We cannot get any better than that, because we have to use powers of 2. It's just how subnet masks work. Remember, a subnet mask is a straight chunk of 1s and then a straight chunk of 0s. You can't separate the 1s and 0s. So it has to be a power of 2. Alright, so in this case, we need 10 bits given to the host. Now, that's going to bring us to what n equals. N equals the number of zeros in a subnet mask. So, we can construct our needed subnet mask backwards. So we need 10 zeros. 1, 2, 3, 4, 5, 6, 7, 8. There's our first octet, backwards. Then we need 2 more zeros. 1, 2. And then the rest are going to be 1s in this octet. And then, of course, we have the subnet that the ISP gave us, which is 255, 255, or straight 1s. We can't touch that. It's already set in stone. So, the parts we can mess with leaves us with 6 available bits. Now, we'll get into the significance of these bits in just a minute. What we're going to do now is we're going to calculate the beginning and the end of this network. So, the first address, of course, we're going to take this address, which is going to be 205.192, and then we're going to break it down again into binary. Now, here we're going to use bitwise operations to calculate our network address. Our first network address is going to be 205.192.0.0 using bitwise. And it's going to run clear up to 1024 hosts greater. So, you take and add 1024 minus 1 to this value. Now, the tricky part is every octet equals 256, and then we're going to move up an octet. So in this case, we have how many 256s? We need to divide 1024 by 256, which equals 4. So that means we have 4 octets completely full of values in this address range. So it's going to go, we need to move that up to the next bit. So another way we can do this actually is if we wanted to, we could also take and calculate how far we need to go to the next address by taking and substituting in another bit. So we put a simple 1 here, which will calculate where our next address is going to start, which would be 205.192. In this case, 4.0. So we need to subtract 1 from that network address to get our broadcast address for the last network, which is 205.192.255.255. With a subnet mask, now take note, you have added 6 bits. So with a subnet mask of 6 plus 16. So slash 22. And then again, you can figure out everything from there. Now, because we don't need our next one to be so big, we're going to need to calculate a new subnet for group B, which is going to start at 205.192.4.0. So let's go back up. And do this again for group C. So this is group A, A's range. This is subnet 1. Now we're going to work on group B's. So if we take group B's, we need 508 users. Again, I did the math beforehand. So we're going to need to use to the 9th power this time. 2 to the 9th power. Because that's going to equal 512. So minus 2. So we'll have up to 510 users. We only need 508, and that's about the closest we're going to be able to get. So, in this case, we're going to use 9 digits in our subnet mask. So our subnet mask is going to be, this time, we're going to have an additional borrowed value, because instead of 10 last time, we're using 9 for the network. So we can go backwards. 1, 2, 3, 4, 5, 6, 7, 8, dot 9. That part is your host address. And then we fill in the rest. And then of course we have 205.192 here. So, we now know our subnet. Our subnet is going to be /23. So, we are going to start at 205.192.4.0 because that's where we left off with the last one. So we need to calculate how far we can get to the next one. So our current address is going to be 205.192. Then .4. And we need to figure out where we're going to go from here, where our next host is going to end. Now, we of course already know where it's going to start based on our last subnet. We need to figure out where it's going to end. Well, we have 512 hosts. So if we add 512 to this number, which in this case is 2 bits worth, then it's going to be 1 before this number. We just added 512 to this number. So it's going to end at 205.192. Oh, this one is incorrect. It ends at 3.255. So this one's going to end at 5.255 with the subnet mask of 23. So now we have our group B. Alright, next we need to calculate group C. Group C, we need 60 users. So the closest one we can get is 64, which of course is going to be 64 users. If we start over here, we've got 2, 4, 8, 16, 32, 64. So we're going to have 5 bits that we need to use. So we're going to start at 0, and we're going to go out this time because we know that 64 is the closest value we get. We're going to go out 64, which is 192.5.63 because our next address starts at 64. Alright. And this one's going to be slash 5 bits over. So we've got 1, 2, 3, 4, 5 zeros. And then 1, 2, 3 to finish that octet. And then we've got a 255. And then we've got the 255, 255 from our ISP. So this number is going to be 208. So our subnet mask for this one is going to be slash 24, 25, 26, 27. Alright, and now we have what's ever left of our IP range, which goes clear to the 205.192.255.255. Alright, that's how you calculate by host. So you see how we were able to find the closest number to these users, one that was not too, one right above the one that was too small. And then we work our way out from there, with networks starting at the end of the last. Okay, the only other formula you guys need to know when subnetting IPv4 networks is, of course, you'll need to know the one for calculating numbers of subnets. So, let's take into an account we've got 2 to the z power is what I'm going to call it. Okay? Where z is equal to the number of borrowed bits. Now, if you didn't notice, we still have this range up here, but every time we took a bit from the host address portion that the ISP gave us, we borrowed a bit. So, if we draw this out and we took 2 bits, then we borrowed these 2 bits from the initial host portion. This is our network ID. This is our subnet, or borrowed bits. And this is our host ID portion. So, these borrowed bits are what we're going to use to calculate the number of subnets. So in this case, because we only borrowed 2 bits, we're going to have 4 subnets. So it's really simple. If you borrow more bits, you're going to have more subnets. If you borrow less bits, you're going to have less subnets but more hosts. Alright, now the activity we did was extremely complex for calculating users, but normally it's really not that difficult. So I'm going to do it one more time with just a basic structure. Except this time we're going to calculate the number of subnets we need. So let's state we've been given the IP range 207.120.5.0/24. Okay. We need to have 18 subnets. We don't care about the host. We just need 18 subnets. Okay? So how we're going to figure that out is we're going to go over here, and we know that the part we can't change, the network ID, is this guy right here. Not ours to change. That leaves us with 8 bits. So, how many bits do we need to borrow to get 18? Well, if we borrow 1, that means we get 2 subnets. If we borrow 2, it means we get 4. If we borrow 3, we get 8. If we borrow 4, we get 16. Not quite big enough. If we borrow 5, we get 32. So we have to borrow at least 5 bits to get a number big enough to have 18 subnets. So how we're going to subnet this is going to be 207.120.5.0/29 because we borrowed 5 bits which we added to what was already given to us. And that means the subnet mask would be 5 bits added onto this number, or /29. So that means that a network would start every 32 addresses. So our next address would start at .32, and then the next one at 64, and then the next one at 96, so on and so forth, clear until you run out of addresses. It's really basic when not using multiple sizes of subnets. So, for the sake of your activities, you guys will be doing basic subnetting, but understand that you can do more advanced subnetting like we did earlier in this discussion. I hope you guys enjoyed. If you have any questions, make sure to email me if you were in my classes. And if you're not in my classes, make sure to post a comment or send me a message on my YouTube channel. And I'll try to get back to you as quickly as possible. Subnetting can be a very complex and hard to understand topic and can take some students a good amount of time and practice before they will get the hang of it. Again, I hope you guys were able to get this. Please leave any feedback so that I know what I can fix. And I hope to see you next time. We'll be talking about subnetting schemes.